Let's start our new topic today, that is a new chapter today, that is haloalkanes and haloarenes. Basically, these are the halogen compounds of carbon, and here let's start with the classification of these halogen compounds. So the first category is called the aliphatic halogen compounds. So aliphatic means where there is no ring, right? There is no loop structure. So these are obtained, these aliphatic halogen compounds are obtained uh, by replacement of one or more hydrogen atoms of an aliphatic hydrocarbon by an equal number of halogen atoms. Now, depending on the nature of the aliphatic hydrocarbon, whether it is alkane, alkene or alkyne, the aliphatic halogen compounds are again of three different types, that is haloalkanes, haloarenes and haloalkynes. Sorry, haloalkanes, haloalkenes and haloalkynes, depending or based on whether it is derived from a alkane, alkene or alkyne. So we'll see them one by one. Haloalkane is again the halogen derivative of alkanes, that is, it is derived from alkane. So this aliphatic will be again divided into haloalkanes, haloalkene and haloalkyne. So these are the three families. Now this haloalkane is okay. Coming to this haloalkenes, these are also known as alkynyl halide, just like the haloalkanes are called alkyl halides. So another name for this is alkyl halide. So when they are there, that means whether we use haloalkanes or alkyl halide, it is same. Then this will be obviously alkynyl halide, and the last one will be alkynyl halide. So this is their family name. Right. So now coming to the one them one by one. Haloalkanes are again classified as, they will be again, it may be fluoro, chloro, bromo or iodo compounds according to the type of halogen present. And then again the division, there is again a division, that is whether it is monohalide, dihalide, trihalide or tetrahalide. So monohaloalkane or tri di haloalkane or trihaloalkane or tetrahaloalkane, that is depends on whether they have 1 2 3 4 halogen atoms respectively in their molecule. Say for example, if it is say C and it is having 4 bonds but 3 are hydrogen and 1 is chlorine, so this is monohalogen derivative. This belongs to the class mono, right? And if we have say something like this, where there are 2 hydrogen and 2 chlorine, so this is dichloro or dihalogen derivative. So this is dihalogen derivative. Coming to the IUPAC name, we should be, and we have already done how to name these derivatives or these compounds, but still if I have to name this, it will be, there are two chlorine at one carbon, so this will be called dichloromethane, as the halogens are always taken as prefixes. They are always taken as substitutes, not as a functional name. Right. Now generally we'll write them as, so this was the monoderivative, same way there will be tri and tetra as well. Now their general formula for haloalkanes is Rx. Now this R represents alkyl group and X is an halogen group. So R is nothing but your alkyl group and X is your halogen group. Now this halogen can be what? It can be fluorine, it can be chlorine, it can be bromine or iodine. So these are the four elements which may be present there. And obviously the first part R will be an alkyl group, so that means this is R, CN and H. The alkane is H2n plus 2, so here because there is one less carbon, so it will be 2n plus 1 H, and after that there will be a halogen. So this is the general formula for alkyl halide, that is monoalkyl halide. As you can see, there is only one X. Right. So these are the haloalkanes. Now alkyl halides again can be further classified into 1 degree, 2 degree and 3 degree accordingly as the halogen atom is attached to a primary, secondary and tertiary carbon atom. Right. So this aliphatic itself, right now we are doing the alkyl halide part, that is haloalkanes. So we have started with haloalkanes, so we are discussing haloalkanes right now. These haloalkanes can be again, so we have seen multiple classifications. So now these haloalkanes can be further divided into 1 degree, 2 degree and 3 degree. 3 degree haloalkanes, depending on whether the halogen which is there in these chain, whether that is connected to a 1 degree carbon or to a 2 degree carbon or to a 3 degree carbon. So for example, if we have CH3, CH2, CH2 and after that bromine. So this carbon is connected to only one carbon. That's why this carbon is 1 degree carbon, right? But if I take say CH3, C, CH3, CH and Br. Now this is 2 degree because this carbon is 2 degree. This carbon is actually a 2 degree carbon and bromine or your halogen is actually connected to that 2 degree carbon. So this is 2 degree for secondary alkane. Same way, if I have say CH3, C, CH3, CH3 and Br. Now this carbon is actually a 3 degree carbon, and because this is a 3 degree carbon, the compound is 3 degree compound. Now again here also this can be a mono, di, tri halogen derivative as per they contain, whether they contain 1, 2, 3 halogen atoms respectively. So that was about haloalkanes and types of haloalkanes. Now Same thing or similarly we see next, that is haloalkenes. As I said, they are also called alkynyl halides. That is, they are derivatives of alkene. So, for example, it can be CH2 double bond CH and after that C. Right? So, this is actually chloroethene. Now, chloroethene is its IUPAC name. Okay, so now these are halogen derivatives of alkene. As we can see here, the monohalogen derivatives where there is only one halogen atom or only one halogen substitute. So general formula for that will be again similar to what we have seen earlier. The general formula for this will be Cn. For alkene it is CnH2n, so it will be CnH2n minus 1, that is removal of one hydrogen and replacement by this halogen. So this is the general formula for mono derivative or monohaloalkene. Right, so this is how this will look like, that is haloalkene. And next one is haloalkyne or haloalkynes or alkynyl halides. So the haloalkyne will be again similar to this, that is they'll have one chlorine atom replaced, or one chlorine atom will be replacing one hydrogen in a alkyne. So that means, suppose this is the simplest alkyne, right? C H, and here there was H, so remove that and instead add this Cl. So this is our haloalkyne, right? The name for this will be chloroethyne, because this is substitute, this is derivative of ethyne. Done. And if we have to come up with the general formula for this, that will be CnH. No, general formula for alkyne is CnH2n minus 2, but again there will be loss of one more hydrogen, so it will be like this. So this is the again general formula, but only for the mono halide, not for di and tri. And for di and tri, again we lose one more hydrogen and add one more halogen, so that will be the only difference. Now this was the first category, that is aliphatic category. Now let's move to the second category, that is aromatic category, right? And that is called aromatic halogen compounds. Right, so this is our second category. First was aliphatic, now aromatic. Again, these are obtained by replacement of one or more hydrogen atoms of an aromatic hydrocarbon by an equal number of halogen atoms. Now these aromatic halogen compounds will be again or further classified into two major categories, that is nuclear halogen derivatives and side chain halogen derivatives. So I think it is clear. So this will be again divided into two, that is nuclear aromatic derivatives or nuclear halogen derivatives. So here your the chloride or the bromide or basically the halogen atom is attached directly to the ring. The derivative of aromatic compounds in which the halogen atom is directly attached to an aromatic ring. This X is directly attached to a ring. Which type of ring? Aromatic ring. Now, such type of compounds will be called aryl halide. This family is called aryl halide, right? And we will represent it as Ar for alkyl aryl group, R for alkyl group. Same way Ar is for aryl group, and that will be connected directly to the halogen atom. So, for example, you can think about this benzene ring, and this will be directly say for example fluorine will be directly connected to this benzene ring, so that is chlorobenzene. Same way there can be another aromatic ring which already has a substituent. Say for example it has a CH3 molecule, I mean CH3 substitute, and on top of that it is also having a bromine atom connected like this. So this position is called or para position, right? So now if we have to name this in IUPAC nomenclature system, so this numbering will start from here, and this is 1 bromo 4 methyl benzene, right? So this is position 2, 3 and 4. So 1 bromo 4 methyl benzene. So this is connected, the bromo or the bromine is connected directly to the aromatic ring. So that is our aryl halides. And next category is in this aromatic itself is, as you must have guessed by now, that will be called side chain derivative, not the nuclear halogen derivatives, but side chain halogen derivatives. So that is side chain halogen derivatives. This is the second category, and by the name itself it is clear that the halogen is not going to be connected directly to the ring, but the halogen will be linked to one of the carbon atoms of the side chain carrying the aryl group. So this is actually called, the name for this one, a single name, just like we have said aryl halide in the first case. Here the name which we use is aralkyl, aromatic as well as alkyl. So aralkyl halide, right? So this is the common name for this. So the examples will include compound like this, say a benzene ring, and in that ring there is this, say for example take little complex example, that is CHCl2. So this is a dichloro derivative of benzene ring, but the chlorine is not directly connected to the ring. So now how we are going to name it? So the substituent which you see here, that is CHCl2, that itself is a complex substitute, so we have to name that first. So that is actually 1,1 dichloro, 1,1 dichloro and phenyl methane, right? So that is So our main chain is this carbon atom. I mean, this is actually a methane derivative of methane. On methane, there are three substitutes. There are two chloro and there is one aryl group, which is actually a phenyl group here. So we say that it is 1,1 dichloro and then at the same position 1 there is a phenyl group. So 1 phenyl methane. Now notice here that this benzene ring is not the main chain anymore in this particular case. Why? Because this, if we take methane as methane as the main chain, there are three substituents. But if I take phenyl or the benzene as the main chain, there is only one substitute. So the number of substitutes when we take methane as the main chain is 3. So that's why that is our main chain. Right. So that is about the side chain halogen derivative. Now these were the classification that was based on whether it is derived from aliphatic compound or an aromatic compound. The next classification is actually based on the basis of type of hybridization of carbon bonded to the halogen atom. So the carbon which is bonded to the halogen atom, that carbon can have sp3, sp2 or sp hybridization, and based on that again we have few different types of haloalkane, I mean uh, classes of halogen derivatives. So say for example we will have say compounds containing sp3. So where there is a sp3. So first let us say this is classification based on hybridization of carbon attached to halogen. So this is actually based on hybridization, classification based on hybridization of what? Of the carbon. So it can have sp3, sp2 or sp hybridization. Now if we consider only for sp3 hybridization, let us consider the case of where carbon is sp3 hybrid or in the sp3 hybridization state. Now again there are 4 types in that. That will be when these are connected to alkyl, that is say for example Rx. First is this, and this again can have 3 possibilities: 1 degree, 2 degree and 3 degree. Now this category is simple. I mean the name for this category is, we have already seen, such compounds are called haloalkanes, or they are also called alkyl halides. So these alkyl halides will be those compounds where it is derivative of alkane. So all the carbons are obviously sp3 hybridized. Okay, coming, and this we have already discussed, so leave it here. Even say for example this compound, if you see this is directly connected, this halogen is connected to carbon, and that carbon is actually a sp3 hybrid carbon. So this carbon, we always have to see the carbon which is connected to the halogen, and that is sp3. So if it is sp3, it belongs to this haloalkane, and this is the carbon which is connected here that is connected to only one carbon, so that is actually 1 degree. So this is again a primary haloalkane. Right, but suppose we have this uh, right, and this halogen is directly connected to this. So now the carbon which is connected here, this carbon is connected to two different carbons. So now this is a 2 degree and it is still sp3. So it is sp3 but 2 degree. Same way there can be sp3 but 3 degree as well. So all these are possible. Okay, next move to the next category in the sp3. So our main category is still where carbon is sp3, but we are seeing different variants of compounds where we will have 3D sp3 carbon, but different variations of that which we have seen here. That is haloalkane, the first one. Next, which we have already seen, this is called allylic halides. Right. So again, this is important. We'll see them one by one. Allylic halide. What is allylic halide? In these halides, the halogen is linked to sp3 hybrid carbon atoms, and that sp3 hybrid carbon atom will be next to a carbon-carbon double bond. So there should be a carbon-carbon double bond. Next to that carbon-carbon double bond, there should be a carbon. That this third carbon which we are talking about, that should be sp3 hybridized. So an example for this will be something like this. So if you see here, this is position 1, 2 and 3. There are 3 carbons. Carbon 1 and 2 have double bond. Carbon 3 is next to the carbon which is having a double bond. And suppose here you have CH2X. So that means there are total 3 carbons, and the X is connected to a sp3 hybrid carbon. So it still belongs to this section, so there is no problem in that. It is sp3, but it is next to the carbon-carbon double bond. Now that is called an allylic halide, right? And there will be multiple. You have to just identify this pattern, the definition, that there is a double bond between two carbons, and the next carbon, that is, say for example this is connected to a halogen, right? So this carbon which you see here, to which the halogen is connected, this is sp3, and this is connected to carbon-carbon double bond. So even that is nothing but belongs to the allylic halide family. Coming to naming of them, as we have seen, the double bond or the multiple bond gains or has higher priority or preference than the halogen derivatives. So numbering will be as you have seen here. Even in the case of this ring structure, it will start from here, right? So I'll name this the ring compound for better understanding. So this the derivative, the substituent is at position 3, and that is halo. So this compound will be 3, whatever that halogen is, bromo, chloro, hydro, whatever, 3, say chloro, cyclo, hex 1e, and it is a, again, that carbon which is connected here, the carbon which has this halogen connected to it, that is again connected to two carbons, so that is actually a 2 degree. So we can always find what is the degree of that carbon, or whether it is primary, secondary or tertiary halogen. So that division is always there, whether it is mono, tri or di, that division is also there, always there. But right now the divisions which we are seeing is based on the carbon, the sp3 carbon, that the halogen is connected to sp3 carbon, and then that sp3 carbon is connected to what. So if it is just a alkane and derivative of that, it will be called alkyl halide. If it is like this situation which we have seen here in the second case, this is called allylic halide. Okay, next is the next category is again an important one. This is called benzylic halide. So from name itself you must have got the hint that it will be again a benzene derivative. The halogen is attached to, this category is sp3 carbon. So the benzene will be attached to sp3 hybridized carbon atom, and that carbon atom is next to an aromatic ring. So the second case, the carbon atom is next to C double bond C. So let us write that because it is not written here. Carbon attached to, or I'll say XC attached to uh, carbon carbon double bond, and here I'll say the sp3 hybrid carbon is next to an aromatic ring. The CX, that is sp3 hybrid carbon, is attached to a benzene ring, right? So what does it mean? There will be a benzene ring, to that there will be a carbon attached, so it is sp3, and so sp3 is attached to a double bond carbon here as well, but it is not allylic, it is benzylic. It is special case for allylic. Now this will be connected to, say for example, CH2X, right? So this is your benzylic halide, and as you can see here, this carbon is sp3 to which it is attached, so no problem here that it is sp3, so this belongs to this category. And this is the carbon is attached to only one carbon, so this is a 1 degree compound. So as I said earlier, this division is always there, right? And it can be 1 degree, 2 degree, 3 degree, that is all of these are possible, right? So this is our benzylic halide. There is a fourth category in this as well, and that category is called pro propargyl pro propargyl halide. Now what is this category? One thing is for sure, the carbon to which the halogen is attached, that is going to be a sp3 hybrid carbon, right? The halogen attached to that sp3 hybrid carbon, and that sp3 hybrid carbon is next to a carbon carbon triple bond. So this XC, where C is the sp3, is attached to a carbon which is having triple bond with another carbon. So example for this is again simple, say CH triple bond C, and that is having a sp3 carbon, and that will be connected to, say for example, here in this case bromine. So the name for this is, again, the multiple bond has the highest priority, so the name here is 3 bromo 3 bromo. There are 3 carbons, so 3 bromo propine, right? So now the ine, the double bond, the triple bond can have multiple possible positions. It can be at position 1 as well as position between 2 and 3. So we have to use the number here, that is prop 1 I, and as you can see here, this is a 1 degree compound or primary compound, right? So that was about the compounds containing carbon, the carbon which to which the halogen is attached. That carbon is sp3 hybrid carbon. Now that particular carbon can be even sp2 hybrid carbon. So that is the second category in this uh, system. So let us say where the carbon is sp2. So we have a C carbon which is sp2, and that is connected to halogen. So this is the second category. And now this compound, where the carbon will be, the halogen will be directly connected to the carbon which is having a which is having sp2 hybridization. That means the carbon is having multiple bond, mainly double bond. So there will be a double bonded carbon, and this halogen will be directly attached to that doubly bonded carbon. So for example, this IUPAC name will be called haloethene, right? Now even in this we have two categories. So one category is called vinylic halide, and the one which we have just now seen, that is called vinylic halide. So this is the first category here, that is vinylic halide, and we have already seen that the halogen is attached to one of the carbon atoms of the carbon double bond, which we have already seen. And the second category in this is actually called aryl halides, and this aryl halides we have already seen, that is the carbon will be part, the carbon carbon double bond will be part of a aryl or benzene or its derivative. So something like this we have already seen this. So now if this halogen is connected to any carbon, that carbon is a sp2 hybrid, and that is part of the ring. So this is the second category called aryl halide. Done. And that was about carbon sp2. Now let's move to carbon, where carbon to which the halogen is attached is sp hybrid. So there is a carbon having sp hybridization connected to a halogen. So this is our next or the last category based on hybridization. Now in this category, uh, it's a simple category having, say for example, C triple bond C and halogen attached to 1. So again there will be 1 degree, 2 degree, 3 degree variance here, and these are the compounds. In these halides, halogen is directly attached to one of the carbon atoms of the triple bond. That's all. So this is 1 degree, there can be 2 degree, 3 degree, and so on, right? So that is okay. This carbon to which there is a triple bond carbon that can be attached to only one carbon, right? This carbon cannot be, or this will not have 2 degree and 3 degree possible. So in this case there will be only 1 degree possible. So that was about different types of halogen derivatives which we have seen. In the next section we'll cover the nomenclature. I think the nomenclature we have already done, so I'll come to nomenclature later, and before that we'll see some methods of preparations of haloalkanes, and then we'll move to different types of chemical reactions of haloalkanes in the later sections. So that's all for the time being. I'll cover some new topics in other videos. Thank you.